Hey everyone, so today, since it's another asynchronous day, I just wanted to go over a concept we haven't seen before because you guys do have an assignment that is due um, on Canvas. And so I just wanted to go over graphs of exponential functions and transformations. So I have this posted right here, or I will have these notes posted after I'm done making this video, but these are just notes from a textbook I have. And I really like that it's using this example right here, where it uses 2 raised to the x and 1/2 raised to the x for our functions that we're comparing. Because if you remember, those two functions are the exact same thing as the paper folding assignment we did, where when you would fold the paper, the multiplier would be 2 in terms of how many more squares would show up on the paper. And then when we were checking the area for the paper, 1/2 was the multiplier for the the total area of the paper, as in like how many, after we would fold the paper, how many of those pieces of paper would make the full sheet. So right here is f of x raised to the 2x. See how it grows and it keeps going up. And g of x raised to the 1/2 x. It kind of has its larger numbers here on the left side, and it increasingly goes towards 0. And just another really important thing to tell. Obviously, remember we said this before, but I have this written right here. So any number raised to the 0 power will always be 1. So that's why the intercept for these two specifically, 2 raised to the 0, as in f of x, is going to be 1. And then 1/2 raised to the 0 is going to be 1. So remember, this is saying when your input is 0, your output is 1. Input is 0, output is 1. So looking at the properties fully written down, obviously the domain is going to be all real numbers. So that's all real numbers is the same thing as saying negative infinity to positive infinity. The range is going to be all positive numbers. So that means that the range is going to go from 0 to infinity. And obviously, remember, range is the y values. And then it's saying if b, as in the number right here, this multiplier, is greater than 1, then the function is going to be increasing in concave up. Hence, why we have f of x, right? So I'll put that right here. If b is greater than 1, the function is increasing concave up. That's this function right here. Then it says if b is greater than 0 but less than 1, then the function is decreasing and concave up. So that would be g of x in this situation. So it's decreasing, but it's still concave up, as in it still looks like it's going upwards. And then, as mentioned earlier, the y-intercept is 0a. So remember, 0 is your input, and then a, the number right here outside the multiplier, because obviously this raised to 0 is going to be 1, so it's saying that that's going to be a, because obviously b, it doesn't matter what number b is, b raised to 0, which is our input, is going to be 0. I mean, b raised to 0 is 1. It doesn't matter what b is, whether it's a positive, negative number towards infinity, or a fraction, it's going to be 1. So then a times b raised to the 0 is always going to be a. So that's what it's saying right here. That's what the y-intercept is, and that is a question that you will be doing today. So this example says, and that was, so now we're getting into transformation. So it says, use your calculator to graph the following functions. Describe how these graphs compare with the graph of h of x is equal to 2 raised to the x. So the first one we have here is plus 3 on the outside, and then the second one we have here is x plus 3, but the plus 3 is on the exponent. So I put both of these in the graphing calculator for us to compare. And obviously, right here on the plus 3, see, it looks like a regular 2 of x, but there's a big distance right here, so it looks like the graph moved up 3. And then this one right here, it looks like our graph moved towards the left 3. So That was just a graphing calculator. I know it looks a little funky, so that's why the textbook shows them for you more in a lot neater of a way. So remember, this is the original function, 2 raised to the x. That's how 2 raised to the x looks. This is how it looks when plus 3 is on the outside, so that's just a shift upward 3 units. And then right here, plus 3, it looks just like this graph. See, these graphs are the same, except this graph got shifted 3 units to the left. And it says that in writing right here. And remember, the main thing that it changes, like it says here, it has a horizontal asymptote at y is equal to 3 instead of y is equal to 0 for B. And then obviously the y-intercept changes on C. And as a quick reminder for everybody, and I just copied this from the notes that I did post in Canvas as well too, or like our note sheet. An asymptote is a line that a graph approaches but does not touch. So that's the other big thing about exponential equations is when you have numbers that you're, so when we have 2 raised to the x or 1/2 raised to the x as our functions, right? These graphs, they can be negative numbers, but only if the negative is here on the outside. So that means that, and I'll go back up to here really quick just to explain it. Remember, 2 raised to the x is always going to constantly increase and it's going to get towards infinity. And 1/2 raised to the x is always going to get much smaller from, the origin 0, 0. But it's never going to touch 0 because, and this brings us to an important concept, and I'll grab the calculator real quick to show you. But remember, 2 raised to the x, it doesn't matter what our number is, those numbers are always going to exist, right? And I just wanted to show you an important concept. Usually, sometimes when negative numbers are used, that indicates the inverse. So like we were showing, or I don't know if I showed this in class yet, but let's say 2 raised to the negative 1. I don't know what you guys think this value is, but just think about it for a second and ask yourself, what could 2 raised to the negative 1 mean? And it's actually on the screen too, by the way. But so when we calculate this, 2 to the negative 1 is 0.5. So why is it 0.5? Or I'll show you one more example. Let's do 2 raised to the negative 3. 2 raised to the negative 3 is 0.125, or this is the same thing as saying 1 divided by 8, just to show you guys the decimals. So those numbers are true because 2 raised to the negative 1 is just the inverse of 2 raised to the 1. And what is the inverse? That is, so the inverse of 2 is obviously 1/2. So 2 squared is 4, right? So the 2 raised to the negative 2 is the inverse of that. So that would be 1 over 4, or it's the same thing as saying 1 over 2 squared. And I'll show you just one more example too. So let's say 2 raised to the 6, right? That's 2 times 2 times 2 times 2 until you get, 6 2's, right? So that is 64. And then when we look at 2 raised to the negative 6, that is 1 over 2 to the 6, or simply just 1 over 64. So that's why in these situations, as long as there's not a negative number outside of the graph, and I'll get into an example like that in just a second. Remember, these graphs, and for that reason right here, when it says the range is all positive numbers, no matter what, we're always going to have a fraction, and these numbers right here are never, they're going to get really close to 0, but they're never going to touch 0. Same thing with 2 raised to the x. When you go into the negative side of it, it's going to get close to 0, but it's never going to touch 0. So in the situations where it touches 0, because you are going to see those, we have two things. We have two things that can alter the two other things that alter the graph. Negative f of x, or if the negative is on the outside, that means that the graph is going to be reflected about the x-axis. And then if the negative, so yeah, this is just showing that if the negative is on the outside of the equation, then we're going to reflect about the x-axis. If the negative is, like if it's 2 raised to the negative x, that's indicating this one right here, where it's showing that we're going to reflect about the y-axis. And I put these in Desmos just to show you. So remember, we're just looking at f of x is raised to 2 raised to the x. That one right here is just, that's our red one, so that's the original function, just the regular one that we saw online. So this is the first situation that it shows on the number one. It says when the negative is on the outside of the function. So if the negative was on the outside, in that situation, yes, we're going to reflect it about the x-axis. So that's why those negative numbers can exist, is because we do the calculation first and then we apply the negative number. So that's the only reason why the negative number exists in that scenario. And then for h of x, we put the negative on the x. So when your input is 1, your output is negative, or that means you're plugging in -1, because the negative is just waiting for the input to happen and then it immediately makes it negative. All that does is just reflect around the y-axis. So it makes this graph essentially look like 1/2 raised to the x. And yeah, using these notes in this little mini lecture, just complete those 3 little questions that I have in modules, and I'll show you where it is real quick just in case. But it's going to be in modules, and then snow day assignment, and here's the list, and here's the PDF right here. So yeah, just complete these 3 questions, and that's all I'm asking for today. I also have the format right here just in case you're confused as to what to answer. But yeah, thank you for your time and have a good day.